Okay, welcome my geometry students to your Chapter 12 quest review on YouTube. This is a big quest, Chapter 12. A lot of material, as you see from your note cards. So hopefully these 8 problems will help you out. Number 1 here. It says, in the circle, what is the value of x? And notice, x is the radius. So really, we're finding the radius of this circle. Now, you have a radius here. And this 14 is a tangent. So this right angle, you should know. They should not have to mark that. So when you have a radius hit a right tangent, that is a right angle. And we can use Pythagorean Theorem to solve this problem. Now, the one thing I need to caution you on is this hypotenuse. Part of it is x, part of it is 10. So the length of that hypotenuse is x plus 10. Okay, so make sure you understand that when you use Pythagorean Theorem. Okay, so we are going to use Pythagorean Theorem. A squared plus b squared equals c squared. C is the hypotenuse x plus 10, so let's let a be x squared plus b is 14 squared equals c is x plus 10 squared. So on this left side here, it's just x squared plus 196. And on the right side here, this x plus 10 squared, what that really means is x plus 10 times x plus 10. And you must multiply that out or FOIL it, however you want to call it. So when you multiply it out, you get x squared plus 10x plus 10x plus 100. And now you should simplify this right side. So x squared plus 196 equals x squared plus 20x plus 100. And now notice you have a x squared on each side. So if you were to try to combine the like terms across the equal sign, you would subtract an x squared, you would subtract an x squared. They're actually going to cancel. And now this no longer has an x squared. It's no longer quadratic. It is now simply linear. X to the first power. So get x by itself by subtracting 100. So that says 96 equals 20x and divide by 20. And we get an x value of 4.8. So I just want to do this problem to warn you of the x plus 10 squared, understanding that it is this FOIL problem. Okay, so just be aware of that. 2 here. The belt problem. Here it is. It says a belt fits snugly around 2 circular pulleys. So the belt is going around the pulleys like this. This is the belt. It goes around. That's bad. But it goes around. So it's this. It's going around. Comes back up. That's the belt. Okay? And these are the 2 pulleys, the circles. So it says segment CE is an auxiliary line. So be aware of what this auxiliary line is. It's just a dotted line that really wasn't part of the picture, but they drew it in. Now they drew it in from E to segment BD so that it is parallel to BA. So there's these arrows meaning parallel. And that's important. Okay. So all I care about is part C. Part C says, what is the distance between the centers of the pulleys? And that is simply, what is the distance from D to E? So what is DE? That's what we're looking for. What is that distance? Call that X. Okay? So there are a couple things you need to do. First of all, you have to see this triangle. This is what we're going to try to use to find X. This triangle. Okay? So let me draw that down here. No, I'm just going to leave it there. Okay. So we need some things in this triangle. Well, let's see what we got. Well, in the top quadrilateral, A, B, C, and E, this thing, okay, these B and A are points of tangency. EA and DB are radii. When a radius meets a point of tangency, perpendicular. And because these 2 sides are parallel, these 2 angles are also right angles, and what we have here is a rectangle. So ABCE is a rectangle. This top figure. So this one right here. It's a it's a rectangle. So opposite sides are congruent. So if this is 35, so is that. And if this is 8, so is that. Which forces this right here to be 14 minus 8, or 6 inches. And now, I'm going to take a look at this triangle. Make it a little bit bigger. Here's D. Here's E, and this was C. This is now 6 inches. This is 35 inches up here. I want to find this X. And because of this right angle here, that is also right angle, and that's right there. There's your right angle. Here is your right triangle. Let's use Pythagorean Theorem. A squared plus b squared equals c squared. C is your hypotenuse, x. So let's go 6 squared plus 35 squared equals x squared. 6 squared plus 35 squared, that's 1261. And we'll do the square root. Remember that you always get 2 answers, but we're just going to keep the positive one. So when you take the square root of that, you get 35.5. And that is the distance between the two centers of the pulley, 35.5 inches. Okay. So be aware of this problem here, the belt problem. Next, find the value of x. Now notice x here is again a radius. Alright, now in this problem we have this O to this segment being perpendicular to this chord. So my suggestion here is, why don't we extend this and create a diameter. And now we have a diameter perpendicular to a chord. That means it also bisects the chord. So if this chord is 8, 4, and 4. And why do we need that? Well, I want to create a right triangle. Now, x is my radius. Has nothing to do with these down here, but I can draw another x in, right? There. And now, focus on the right triangle. This one right here. This is x. Here's your right angle. This is 4. And that's 3.6. And I want to find x using Pythagorean Theorem. A squared plus b squared equals c squared. My hypotenuse is x, so let's go 3.6 squared plus 4 squared equals x squared. 3.6 squared plus 4 squared equals 28.96. That's what x squared is. Take the square root, take the square root. Again, 2 answers plus or minus. Just keep the positive one. 5.4-ish. And there's the value of x. So be aware of that radius and the fact that you can move it. Okay, and also, if a diameter is perpendicular to a chord, it also bisects the chord. 4. Okay, getting into the nitty-gritty, the section 12.3 and 12.3 and 12.4 problems. Here we go. Excuse me. Number 4 here. We have a picture of a circle with an inscribed quadrilateral. We need to find A, B, C, and D. I'm going to start in the circle. The angles C and D are going to be supplementary with their angles opposite them. So C is going to be 180 minus 96. So C is 84. D is 180 minus 100. So D is 80. And that's a corollary to the inscribed angle theorem. Okay? And now we need to find A and B. Well, A and B are part of arcs. So we're going to have to use the inscribed angles here and the arcs. Now, each angle is going to intercept 2 arcs. So I'm going to look at this arc created by the 99 and the A. And if I follow it back to the angle that it follows back to is the 100. The 100 degree angle is an inscribed angle. It's equal to half of its arc. Now, because the arc that 100 intercepts is made up of two smaller arcs, I need to add those 2 smaller arcs together. A plus 99 times 2 times 2, 200 equals the 1/2 and the 2 cancel. A plus 99, subtract 99. A equals 101. So there's A. I'm going to put that on the picture. And now we're going to do the same thing with the 101 degree arc, and now B. Okay, so there are two adjacent arcs. They belong to the angle C, and we found angle C to be 84 degrees. So we set up a similar equation. The angle 84 is equal to half of its arc. Now again, this angle intercepts two arcs, so add them together. B plus 101. I'm going to multiply both sides by 2. 168 equals B plus 101, and I'll subtract 101. 67 equals B. So be very careful with this problem and the finding the arcs. Okay. All right, 5 here. Let's remember that this is not part of the work. Okay. So find the values of each variable, A, B, and C. Okay. So notice here in this problem we have a central angle. See the center? This 44 degrees is for this angle. The measure of the central angle is equal to the measure of the arc. So that arc is also 44. And why do I care? Well, look at where A is. Here's A. Trace its sides. A is on the circle. It's equal to half of its arc, and its arc is 44. A is equal to 1/2 44. A is equal to 22. Now, B is also, we can call it an inscribed angle, but it's formed by a chord and a tangent, but it still is equal to half of its intercepted arc, which is this arc C. So our equation here, B equals 1/2 C. Now I can't have two unknowns, I need to know one of them, so I think I can find one. And the one I'm going to find is C. If you notice the two arcs that we already have, we have 160 and 44. Add those two together. That is 204. That is 2 of the 3 arcs that make up the circle. So to find C, I'm going to take 360 minus 204. So C is going to be 156. So now that I have C, I can find B. B is half of 156. B is 78. And there you go. Okay, a couple more left. Number 6 here. Find the value of each variable. Okay, so we need to find x and y here. Now, notice, x is an angle, and it is inside the circle. It's not at the center, it's inside. So it's going to be equal to half of its half the sum of 2 arcs. Now, if I use red here, if this is x, here's the angle. So trace its arc. So one of the arcs is here. Well, notice where this angle ends. It ends on a diameter, so that is a semicircle. 180. So there's one of the arcs. The other arc is going to be its vertical angle's arc. So this angle would intercept that arc. Now, can I find that arc right there? Well, sure can, because 60, that arc, and 70 make up a semicircle. 60 plus 70 is 130. 180 minus 30 is 50. This is a 50-degree arc. And now I can find x. X is equal to half the sum of 180 plus 50. Half the sum of the 2 arcs it intercepts. That is going to be 230. Half of 230 is 115. And there's x. Okay. And now we need to find y. Now y is an arc. So what is the angle associated with it? Well, it's the 53-degree angle, which is outside the circle. Outside means half the difference. So if I look here, okay, here's the angle. There's one side, there's the other side. So it intercepts this closer arc y and this larger arc here. And again, notice 53 ends on the diameter, so this larger arc is 180 as we used here. So the two arcs we're going to subtract are 180 and y. So the angle 53, I'll do it right here, equals half the difference of the farther arc 180 minus the closer arc y. I'm solving for y, so let's multiply both sides by 2. That's 106 equals 180 minus y. The 1/2 and the 2 cancel. And now let's solve for y by subtracting 180 and dividing by -1. And y is 74. Okay, so be careful here with these angles inside and angles outside of the circle. Next one here. Find the value of each variable using the given chord, secant, and tangent lengths. So this is going to be a segments problem. So we're dealing with segments here. So remember, there's 3 different ones. There's chord, secant, tangent. Remember, chord is parts. Secant is whole times outside part. And for the tangent, you square. Okay, so remember, that's how you handle those 3 different segments. So let's see what we have here. Well, 11, this is the tangent. This 9 and this y, that's a chord. And then this 7 is on a secant. Okay. So what can I find? Well, let's use the tangent because I know it. And look at this secant, because the tangent secant is one of the combinations. And now notice the secant, 7, x, and 5. I can do this because I have one unknown, x, out of all of these lengths for the secant and tangent. So to find x, I'm going to use a secant and a tangent. Okay, so the first thing I do here in my picture is I need to label the length of the secant, the whole length. Okay, so this secant, I'll do it in blue. How about I do it in blue? So this secant is 5 plus x plus 7. That's x plus 12. So when I do this secant tangent, the whole length is x plus 12 times the outside part, which is just that 7, equals, and then the tangent I square. Distribute the 7. And now solve for x. Subtract 84, 7x equals, this is 37. And then divide by 7. And x is 5.3. And now, knowing that x is 5.3, we can find y. Y is on a chord, okay? So for y, we're going to have to use the 2 chords case. So to do that, okay, so I'm going to use 5 and x, so 5.3. And on the other chord, 9 and y. And that's how I'll find y. So 5 times 5.3, that's 26.5 equals 9y, and I'll divide by 9. And y comes out to be about 2.9. Okay. So in this picture with a secant, tangent, and chord, notice that we use 2 chords because a chord is part of a secant. So this right here, this chord right there, that's part of that larger secant. So that's why the 2 chords were here, even though there's only 3 segments. There's a chord, a secant, and a tangent, but that part of that secant is also a chord. Okay, last one here. It says, write an equation of a circle with diameter AB. So they give me endpoints of the diameter. I need to find the equation of the circle. Well, let's recall the equation of a circle. X minus h squared plus y minus k squared equals r squared. Now, to find or to answer this question, I need h, k, and r. H and k are the center. These 2 points are the endpoints of a diameter. But the center is on this diameter, right smack dab in the middle. So to find the center, we're going to use the midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2. That'll be 0 plus 8 divided by 2, 0 plus 6 divided by 2. So the center is going to be at 8 divided by 2, which is 4, 6 divided by 2, which is 3. And now we need to choose one of these points as our x and y. Now, if I was to do this any other way, I would choose 0, 0. But because I want to show you the true, distance formula, I'm going to pick 8, 6. But you should pick 0, 0. You should pick 0, 0. So now we plug in 4 and 3 for hk, and 8 and 6 for xy. We'll do it down here. So we have 8 minus 4 squared plus 6 minus 3 squared equals r squared. And remember, I'm looking for r, or I could just look for r squared. It's up to you. This is 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. That is my r squared. That is as far as I need to go. I don't really care what r is. All I care about is answering the question. X minus 4 squared plus y minus 3 squared equals r squared. There we go. This last number should never be squared, right? There shouldn't be a little 2 there. It should always be multiplied out. There should never be a square root there either. Okay. Notice that the center's coordinates are positive, so they are minus signs in the formula. Remember, if those were minus signs, you'd pull out negative numbers. Okay. And then the last thing I want to do before the very end is graph this real quick. Okay. So here's my graph. My center's at 3, 4, and my radius. So now I do want the radius. So if r squared equals 25, square root, r is 5. Okay? And let's go 9 in every direction. There we go. Just a quick rough sketch. And I'll do it in orange here. So we go 4, 3. So 1, 2, 3, 4, 1, 2, 3. We mark the center. And then we count the radius 5 in all 4 directions. Up. To the right. To the left. And down. And we connect those 4 dots with the best circles of our lives. There we go. And there's that circle graphed. Okay. Thanks for watching. This is a very thorough video, so hopefully you feel comfortable. Again, I think we touched on most of those 12 note cards. Make sure you get those done for Friday or Monday. All right. Thanks for watching. We'll see you then.